How to efficiently compare two unordered lists, not sets. A and B should be considered equal, because they have exactly the same elements, only in different order. The thing is, my actual list will consist of objects, my class instances, not integers.
You can sort both. A counting sort could also be more efficient, but it requires the object to be hashable.
The best way to do this is by sorting the lists and comparing them. Using counter won't work with objects that aren't hashable. This is straightforward for integers. It gets a little trickier with arbitrary objects. If you care about object identity, i.e., whether the same objects are in both lists, you can use the id function as the sort key. In Python 2.x you don't actually need the key equals parameter, because you can compare any object to any object. The ordering is arbitrary but stable, so it works fine for this purpose. It doesn't matter what order the objects are in, only that the ordering is the same for both lists. In Python 3, though, comparing objects of different types is disallowed in many circumstances. For example, you can't compare strings to integers, so if you will have objects of various types, best to explicitly use the object's ID. If you want to compare the objects in the list by value, on the other hand, first you need to define what value means for the objects. Then you will need some way to provide that as a key, and for Python 3, as a consistent type. One potential way that would work for a lot of arbitrary objects is to sort by their wrapper. Of course, this could waste a lot of extra time and memory building wrapper, strings for large lists and so on. If the objects are all your own types, you can define __lt__ on them so that the object knows how to compare itself to others. Then you can just sort them and not worry about the key equals parameter. Of course you could also define __#_, and use counter, which will be faster.
If you know the items are always hashable, you can use a counter, which is O(n). If you know the items are always sortable, you can use sorted, which is O(n log n). In the general case you can't rely on being able to sort or has the elements, so you need a fallback like this, which is unfortunately O(n²).
And the counter method is best if your objects are hashable. And log and the sorted method is next best if your objects are orderable. And *n if the objects are neither hashable nor orderable, you can use equality.
If you want to support the channel, please consider liking and subscribing.